Good afternoon, everyone. Thank you for attending day four of the Illinois Environmental Health Association Spring Virtual Conference. So today we're going to cover wastewater topics and go ahead and get you the rest of your CEUs. Everyone should have received an email this morning from our office with the necessary paperwork to submit to get your CEUs and then give any feedback that you may want to provide to us on the conference itself. If you didn't, please reach out to our office and ask Heather to send you that again. So I hope everyone enjoys. I know I'm definitely looking forward to it. So Arnie, I'll turn it back over to you.
All right, thank you so much, Justin. Thank you everyone for joining us today. We're going to go ahead and get started off immediately with our first presenter. First presenter is Brian with OSHA. So Brian, I'm going to go ahead and turn it directly over to you.
All right, thank you. Like you mentioned, my name is Brian. I work in the Peoria OSHA office. And my plan for today was give you a little bit of insight into OSHA inspections and what we'd be looking for as far as safety and health programs. I'll walk you through our national emphasis programs and some of our regional emphasis programs and what that means, especially as it relates to excavations, which is a big part of what we'll be talking about today. We'll address common violations throughout the process. Hopefully, I'll improve your hazard recognition so that you can make sure that you stay safe. And then, of course, in the end, you'll have my contact information. Feel free to write any of your questions in the chat. But if you don't feel comfortable putting a question that you had in the chat, by all means, you can reach out either by phone or email, and I'll gladly answer anything I can for you, perhaps one of your contractors, or perhaps even a family member. If you have safety or health-related issues that you think should be taking a look at, or you just want to know, hey, what's exactly do our standards say about it? By all means, we'll gladly share that information with you and get you the appropriate stuff. We've been around for more than 50 years now with the same goal to make sure that that employers provide health and safe working conditions. And so we've been doing that now for 50 years. And typically what we're famous for is going out doing inspections. And in those inspections, we end up looking at both what kind of safety and health program the employer has, but then also those specific issues as far as the hazards at the work site. Most of the time, we tell people that we were invited out here. We get invited out to do inspections if there's a work-related fatality, if there's a severe injury, things like an amputation, loss of eye, or even just a hospitalization can result in an OSHA inspection. And we'll talk about how that comes about. We get complaints, and depending on what that complaint involves, we will schedule for an inspection, or we would actually just call up the employer and say, hey, we got a complaint about this issue. And then we also put together lists based on our national emphasis programs. Some of those are targeted inspections based because of the type of industry they're in, and other ones are based on the hazards that those employees are likely to encounter. So we'll get right to it. Each employer is required to call us within 8 hours if they actually have a fatality, a work-related fatality at work. We give them up to 24 hours to contact us for inpatient hospitalizations, amputations, or loss of an eye. You can anyone is welcome to use our hotline. It's 1-800-321-OSHA or 6742. And when you call, if you're calling about a situation, what you're going to want to know is the zip code where that hazard or issue is located. Once you tell them that, they're going to direct it to the local OSHA office. So if you called that now and said, hey, I'm working in 61611, they're going to immediately transfer it to our OSHA office, which is, of course, open. If it happens after hours, depending on what you tell them, for example, if you said, hey, there's just been a work-related fatality at our workplace, they're going to wake somebody up or call or reach out through the phone tree until they reach somebody at the local OSHA office. So those are all parts of what's going to happen. Typically on an OSHA inspection, the inspectors focus on these 4 issues. Is there an employer-employee relationship? Because one of the things we have to show is just that there's an employee who's exposed to this hazard, OSHA has jurisdiction when there is that relationship. We don't have jurisdiction over a homeowner who happens to be doing their own work. So it's critical for us to show that, hey, we actually have jurisdiction here. Then, of course, we're trying to figure out exactly how serious the hazard is that we might be looking at or that that employee might be exposed to. One of the statutory requirements is we have to show that the employer had knowledge of that situation or condition. And then, of course, we have to show that there's a feasible way to protect the employee. That ultimately falls on OSHA's responsibility to show that whatever we're going to ask the employee to do to prevent that hazard is actually feasible. So those are all parts of what will happen on an OSHA inspection. So let's just take an example because perhaps maybe even you've done something as silly as this, getting up on the top step of a ladder. We would see something like that as a hazard. But in order to say it's an actual OSHA violation, we have to go through those previous steps. Is there an employer-employee relationship? So if this is a person who works for themselves and doesn't have that employer-employee relationship, we would not have jurisdiction. Next, we have to show the seriousness of the hazard. And of course, a 6 or 8 foot fall hazard certainly rises to that occasion for us. The next step is how would the employer know that this is going on? Perhaps there's a foreman working near this employee, seeing this sort of activity. And or sometimes it could be that this is the supervisor, right? If this is the person who is management's representative for those sorts of things, it often becomes pretty easy. And then finally, the feasible way to correct it, well, there's all types of different things that we could get this employee up to that area where they can still do the work, where they would not be exposed to the same fall hazard. Perhaps just a taller ladder, and they make all kinds of different lifts and stuff that would allow them to also get there safely. But in lots of cases, the employers will say, well, their employee's not supposed to do that. So what we ultimately do is that we try to evaluate, well, how good is their safety and health program? So when we ask either the employer or the employee, we're going to try to determine those sorts of things. And it's based on these 4 questions. 1, does the company have clear rules or expectations? So what are they supposed to do when they are, they may have a policy that says, do not stand on the top step of the ladder. Okay, great, they have a policy. Next, how do you know the employees understand those rules or expectations? So is there a way to verify that the employee at least heard it, understood it, those sorts of things? So oftentimes, the employer might produce a training record that shows those sorts of things. Next step is, does the company have a process to check on the employees to see whether or not employees follow said rule? If I told you that they never send anybody out to check on the employees who typically work alone, you might say, well, geez, that they're not doing what they should be doing to check on the employees, and we would agree. And that really falls into line. We want to show that the safety and health program has regular checks. And one of the things you're going to see as we talk about the construction standards, it requires a frequent check, not just a, oh, we checked once a month. We wouldn't consider that really frequent for those sorts of things. And then finally, do they have an effective enforcement program? When they found these sorts of hazards in the past, or when they've occurred, what did the employer do? And if they have an appropriate discipline policy and they're getting, employees to change behaviors, then we may decide that this was not an OSHA violation that we're looking at. It was employee misconduct. And we deal with that from the top level. There's been experiences we've had where there was an actual fatality at work. And we showed the employer was doing all of these 4 steps and had a good safety and health program in place. And in our opinion, we decided we should not issue a citation, even though that employee was clearly exposed to a hazard and perhaps even passed away from that injury. So as we talk about the OSHA standards, or as we've talked about, that'll give you kind of a basic rundown of some of the things that the OSHA inspectors are going to be looking forward to doing and trying to make a determination as they go through. The next step is, what kind of safety and health program does this company have? And so we required, while an employer is doing construction work, to have a basic safety and health program that addresses the types of hazards the employees might be encountering, and they're required to have a regular and frequent inspection by a competent person, somebody who's able to recognize those basic hazards. And then, of course, the most important part of that is take corrective action as it's appropriate. And so we want to make sure everybody understands the basic hazards, understands what protocols they should use to stay safe, and how to address those issues should something come up. That's all part of the basic safety and health training that we expect to see on those sorts of things. So let's get us out to the work site. We typically just start with the basic stuff like personal protective equipment, right? That's readily visible. If we see an employee working on or near a roadway, it's within 15 feet of the edge of the roadway, we want to make sure that the employee can be seen. As you can see in this picture, it's difficult to see the employee. Happens to be a cloudy day. He's not wearing bright garments in any way. And he's actually cutting concrete. So that, of course, leads us to look at, are they using appropriate hearing protection? Anytime an employee might have products overhead where they could be struck by materials, and that happens oftentimes in excavations as an employee is down there running pipe or they're moving materials down into there. Even though, the not continuous exposure overhead, we want to make sure that they're protected with appropriate head protection. And then, of course, eye protection is one of those things that most of the time on a construction site where you can have things like you see here where they're cutting concrete, we want to make sure that the employee's eyes are protected, even if they're not the one who's running the equipment. If they are near that equipment, we want to make sure they're protected. As we mentioned earlier, we want to make sure people are visible from roadways and in the roadways. But we also, if you're working, if you will, within 15 feet of the roadway, so maybe they park their vehicle there, whether they're going to be using a crane to move, maybe something in and out of an excavation, we want to make sure that there's appropriate traffic control. Traffic control for us generally means an advanced warning sign. That's why you'll often see the big orange sign that says men working ahead or construction. Some sort of indication as to what's going on, appropriate channeling devices and or barriers, depending on both the speed of the roadway, how many lanes that you actually happen to have, and of course where the work is going to be going on. And then depending on if they are part of a highway system and or at least within the state of Illinois, there are different traffic control setups that are appropriate. I won't belabor that. I just want to give you an idea that the magic number is within 15 feet of the roadway. Even if they're not doing the actual work on the road, we would still look at, do they have appropriate traffic control and or protections for employees working in those sorts of areas. So some of the hot button items for 2025 for OSHA inspectors are these types of industries and or hazards. And so at the top of our list is excavations, which will, like I said, we'll be talking about in a little more detail in just a second, but fall hazards, heat exposures, amputation hazards, lead, silica, and hexavalent chrome exposures, warehousing work, combustible dust hazards, shipbreaking, primary metals, and process safety management. And then we also have regional emphasis programs. And in the state of Illinois, our regional emphasis programs include powered industrial vehicle hazards, noise exposures, grain handling, food manufacturing, and tank cleaning industries, building renovation, high-rise building, wood pallet manufacturing, maritime work, and of course, federal agencies. So those are our areas for emphasis. And what that means is if we get a complaint about something in these industries, and or we also put together lists of inspection in these areas, we're going to do an inspection. So if somebody calls us and says, hey, an employer has an excavation that's 8 feet deep and it doesn't have any sort of shoring or protection to prevent the dirt from coming in on the employee, we put it right on our list of things to do. We don't call up the employer and go, hey, we got a complaint about an excavation hazard. We put it on our list of things to do and go out and do inspection. Now, the most common inspections we end up doing, of course, are fall hazards, because we get a lot of complaints about fall hazards that employees are exposed to. But if we were driving by, let's say going to a noise complaint that we'd had, and we see an excavation, the expectation of the agency is that we're going to stop and address it. We don't already have to see what we consider to be a violation or a specific hazard before we are going to, before we're expected to stop and do that inspection. The other thing I wanted to make sure to kind of address with you, in addition to those emphasis areas, OSHA inspectors typically are going to address these 4 hazards also. And that's because it's the biggest 4 pillars of employees year after year. Fall hazards, caught in between, struck by hazards, and electrocution. So those are critical things that anytime an OSHA inspector is out doing an inspection, if they see something, what we call in plain view, related to these hazards, you can expect them to expand the inspection to address those sorts of things. And so to give you an idea as to what we're talking about when we say fall hazard, it could be something as simple as like we saw earlier with the ladder, to as messy as an employee falling through a skylight. That fatality actually happened up in the Quad Cities. An employee was moving some materials on the roof, trips on the skylight, falls through it, and unfortunately died from those injuries. Of course, ladders, like I'd already showed you the one picture of, a couple of big red flags for us is anytime you're going to be using an extension ladder, we want it to extend at least 3 feet over the edge of the surface that you're going to be getting on, if you're going to be getting on or out of that ladder, like you see in the left-hand picture. And then oftentimes we see A-frame ladders that are not used as designed, right? They're not spread all out like they should be. And we get invited out, especially when employees fall off of these ladders when they're not using them as designed. We had an employee who was caught in rotating parts. This was another fatality investigation that we did. An employee who was engaging the clutch came in contact with those rotating parts. He ended up getting wound up in the material. These are the sorts of things we'd expect it to look like. We don't want to wait until there's a fatality to address those sorts of machine guarding hazards. So we'll address a lot of issues like that. And then, of course, this takes us back to Illinois State University, actually on a Christmas day, where they were some ice had gotten behind the concrete near Hovey Hall. The concrete had broken off, and they were concerned about it either falling down further. So they hired a company to come out and pick up the material. As they went to pick up the material, the strap that they used burst, and the concrete came into the cab and killed an employee. And so we want to make sure that anytime you are near, as a person who might be also inspecting those areas, and you see these sorts of things, you recognize that hazard. This strap was rated for 7,000 pounds. That piece of concrete ended up weighing about 14,000 pounds. The strap burst, and like you can see, it ended up coming through the cab. You got to make sure that you're in a safe place. To give you some more examples, we had a material handling fatality. This is not the vehicle and the pipe where the employee died, but it's the exact same setup as the one. This is one we had a couple of days later where they were also making the delivery. In this particular fatality we had, the truck driver is standing between the cab and the trailer, just right off to the side. And as an employee goes to lift up the load, one of the strap breaks, that pipe comes down and crushes an employee. So we want to make sure that everybody recognizes that anytime you're moving materials, you have the types of stuff that could become a crushing hazard. You recognize that and stay in a safe area for those sorts of things. When it comes to electrical hazards, it's not always the high power voltage that we're looking at. In this particular case, a roofer was up on a roof. He's getting, well, we don't know if he was actually stung or not, but the reason they said he went and used the wasp and hornet killer was because there were some wasps up at the weatherhead. And in the process of spraying the weatherhead for wasps, he ends up making contact with some of the live electrical. If you can see in our picture here, there's 2 uninsulated service clamps. The employee, as he was spraying the wasp and hornet killer, makes contact on his upper arm with that live electrical, is electrically shocked and killed. So those are all sorts of things that we routinely have dealt with fatalities that, to somebody who doesn't deal with it all the time, may be all too common and not recognized as a hazard. So I wanted to share some of those horrible stories So hopefully everybody recognizes them going forward. So let's talk about some of the common citations that we've issued in the past for the types of work areas that we'll be talking about today. And excavation hazards, we'll go through some of those specifics in just a second. We've already talked about the fall and ladder hazards that we routinely see, including going into an excavation, right? If they put a ladder into the bottom of the excavation, we want that ladder to extend at least 3 feet over the edge of the surface as to the level ground for that sort of stuff. Not having a basic safety and health program and training for the employees are something that we've often issued citations on. There are personal protective requirements that might be appropriate for the work that they're doing. Reporting requirements, especially if they've had a severe injury that required hospitalization. Hazard communication, depending on if the employer is using hazardous chemicals at all during the work. Even sealers, some of the stuff like that, caulks, are considered a hazardous chemical. And so we'll talk about hazard communication here in just a second. And then, of course, those electrical hazards that we've already touched on. So let's get into our excavation work. The first thing that's liable to happen when we show up at a work site is that we're going to take a picture. We want to show what the conditions were as soon as we get there. And then we're going to be asking for who is the competent person. Remember, oftentimes, competent person is the ability who has the ability to both recognize the hazards and, of course, take corrective actions. So we want to know who the person is that can do those sorts of things if we see something that we think is dangerous, like we see in the picture right here. As we're looking at this picture, we don't have adequate cave-in protection for that soil to where the employee is even standing. Right? We want to make sure that there's a regular inspection of that work area and, quite honestly, keep people out of harm's way. That's part of the training we would expect to see. So let's go into a little deeper as far as some more excavation work. Lots of times there'll be pipes already running through an excavation. And so as you can see in this one, the employee is going to be, have to hand dig because they cannot use the excavator to get under that existing pipe. And so say they're running something perpendicular to that, just below it, we know people are going to have to be in that area. And so we either want it dug out in an angle where the soil couldn't cave in on them, or use a protective box that's maybe pre-made, or use a system of engineered systems of those sorts of things that can be put into place to make sure people are protected. And the whole reason why is if that caves off, one, soil has a significant weight to it. And so you can see in an 8-foot deep trench, that weight and the speed by which that dirt would fall would feel like getting hit by a truck traveling 45 miles an hour. And then the worst part is you can't just, like we're used to with swimming, get float or get back up to the top. It just, you're not able to get through those sorts of things. So it's critical to make sure people recognize that, hey, we need to have a competent person who designs this excavation that makes sure that we have appropriate shielding, shoring, or sloping to keep people out of harm's way. Typically, if you have plenty of space, you don't have, let's say, a building right next to it or things like that. Typically, we see a lot of people simply using the sloping method based on the soil type. But you have to be able to decide what that soil type is as you're doing that sort of work. And then anytime your excavation is even less than 5 feet, you still have to be doing those regular inspections. The OSHA standard absolutely requires one of those forms of sloping, shoring, once you get 5 feet deep. But even at less than 5 feet, it still requires regular examination because, as I'll show you in a little bit, sometimes the excavation doesn't cave in totally. Sometimes just chunks of material will fall off. So if you ever see any sort of fissuring or stuff like this, like you see in the circled area, those are some of the hot button items for us. And certainly you'd want to make sure you're protected or staying out of harm's way. This is the tools of the trade for an OSHA inspector. We call it a trench rod. Imagine a 20-foot long ruler that can be, collapsed and made larger and smaller. But we'll take a device like this. On the other end of it, and I know it doesn't show up great in my picture, we have what's called a plumb bob attached to a rope. And then, of course, we use basic geometry to show the depth of the excavation and that slope of that wall. We also have devices like an angle indicator that will tell us those sorts of things so that we know exactly what is the slope of the wall as we're looking at those sorts of things. And then, of course, based on the type of soil that you have, that will determine as to what the appropriate slope or angles are. And so there's a test called the thumb penetration test that you can do to try to determine which type of soil you have. Ocean inspectors typically either carry a penetrometer, that's the device that would be stuck into the dirt to give you a measurement as to what the cohesive factors are of that, and then or a Torvain shear, which you can see in this picture. And then this little device will twist, and once it clicks, you'll also be able to get a measurement. Based on those measurements, you will decide whether it's what we call A, B, or C type soil. A is oftentimes what we might think around here as clay. B is typically previously disturbed soil, and C ends up being sandy type soils that you might run into. This was one of the fatality investigations that we did with an excavation. And as we're looking at the types of things the ocean inspector might be looking at, you can see the spoil pile. We typically want to make sure that the dirt that they take out of an excavation is at least 2 feet away from the edge of that surface. You can see here it's not necessarily the case. This excavation in its deepest part was about 7 feet deep and was about 5 feet wide. It was classified as B-type soil. But if you can see at the bottom central part of the picture, there was a big chunk that actually fell off onto the plumber as he was down in that excavation. It struck the plumber in the back, and he actually ended up dying of the internal injuries from being hit, if you will, by that soil as it came down on him. He was able to get out of the excavation, but it was a serious enough injury that he ended up dying from the internal bleeding. So it's those sorts of things that, even though he may not have been covered up by the soil, there's all those sorts of things that can occur. We want to make sure people are certainly protected from those sorts of areas. A couple other things that we see with excavations, we want to make sure that anytime that excavation's 4 feet deep or greater, that they do have a safe way to get in and out of that excavation. Ladder is typically fine to be used as long as you can safely use that ladder in and out. What we don't want to see is people riding in those excavator buckets. We have a long history of serious injuries and or fatalities for people riding up, down, and just even horizontally for some distance in those buckets. So that'll kind of take you through some of the issues we've had with excavations. If you have any specific questions, by all means, feel free to write them in the chat, and we'll make sure that we get those answered here at the end. The other thing I did touch base on, and it's a common OSHA violation, is the hazard communication program. It makes the top 10 OSHA violations each year. We expect that any employer who is going to be using hazardous chemicals develops a list of what chemicals that they have, that they ensure that those containers are labeled, that they obtain a safety data sheet for the different hazardous products that they have, that their employees are provided training, that they have a mechanism to train their employees on any non-routine tasks that they might do from time to time. And then if there's separate, say that there was 2 or 3 different contractors working at a site, we would expect that they would share that information about any hazardous chemicals that the other employees might be exposed to. In 2013, OSHA updated their hazard communication standard to include what we call the globally harmonized system. And so DOT, OSHA, all updated their labeling expectations to address that it's okay to use these pictograms in lieu of some of the basic words for the hazards. And so this is that list that we expect all employees to be trained on so that they recognize that an exclamation mark doesn't mean don't open the box. It means that the products inside may be a simple skin irritant, have some acute toxicity, or could be a respiratory tract irritant on those sorts of things. As we talked about earlier, some of the electrical hazards, certainly one of those issues that we run into is where are the power lines? We expect that the employer stays at least 10 feet away from the power lines at all times. If they say, well, the work we're going to be doing is going to put us closer than that. If you're in central Illinois, you can contact Ameren. Throughout the state, depending on where you are, you can contact that local that has jurisdiction over the power lines, and they will either figure out a way to, either shut it off or cover it so that it can be protected while they're doing the work. The other thing we routinely look at is they may have a need for power at the site, and they're using a generator. Anytime you're working at a construction site, we expect that the electrical is protected with a ground fault circuit interrupter. And unfortunately, there's a lot of generators that don't have a ground fault circuit interrupter built into that. So in those cases, they make a pigtail that would have a ground fault circuit interrupter, and then they can plug in any electrical that they might need into that pigtail to provide safe electrical power throughout that work site. Typically, as you heard earlier, one of the top 4 things that kills people is electrocution. So it's not unusual for us to check to make sure that ground fault circuit interrupter is working and working appropriately. The other thing that we always will be looking at is the extension cords that happen to be in use. The extension cord looks like the one that you see in this picture. It does not maintain its original effectiveness. And unfortunately, we've had fatalities where the outer insulation was damaged, and now that inner insulation, although it's still intact, can present a hazard. So we want to make sure that there's a regular inspection of any cords. If it looks like it's been run over and perhaps internally damaged, we want to make sure that those are removed from service and not used, presenting a hazard to those sorts of things. The other things that can come up is employees are exposed to injuries when there's a problem with either a piece of equipment or something going on in that work area. We want to make sure that while they're trying to do any sort of unjamming the equipment or any sort of servicing activity, that piece of equipment is locked out. So it will not present a hazard to the employees as they're doing that work. Lockout can apply to construction activities, but it's usually during cleaning and unjamming activities that we see the most significant amount of hazards. The basics of lockout is we expect that there's a program or system in place to make sure those energy sources are isolated and that the employer does a check to make sure that that energy is no longer functioning. It's easy to recognize, oh, the electricity is no longer on, and here's our test. It gets a little harder if we're dealing with something like a gas line. Right, we've shut it off, we've isolated that energy source like you see in this pipe, but say that there was 70 foot of gas line pipe after our shutoff. It's those sorts of areas we want to make sure people recognize that there's still 80 foot of gas in the line and do take the appropriate steps to minimize that gas. Oftentimes, if it was something like a furnace, we can shut down the gas line and then burn the rest of that fuel out of that pipe. But there are ways to release or relieve it. And so those are the sorts of things we want to make sure people are doing so that there isn't a hazard in the workplace. Next, I did want to touch on confined space because it's always one of those things that you could encounter. And I just wanted to give you a couple of examples. The basics that we see related to confined space fatalities, oftentimes it's because they didn't recognize the hazards. In other times, they recognize there was a particular potential for a hazard and they don't eliminate it. And then the third way people unfortunately die is they're overcome by emotion. You've probably heard stories where there was a manure pit, they see somebody down in there, and another family member tries to go down and save them, and they also end up dying from, say, hydrogen sulfide or something that happens to be in that space. And so it's critical to make sure employees recognize in confined spaces, here's the steps. And so part of the reason I wanted to share this with you, so that you recognize you can't just jump down in there and try to save them. You have to take appropriate steps, like calling the emergency services, who will have the ability to put on an SCBA and go down into an area that does have a hazardous atmosphere. And so we'll talk about our first one here. This is a concrete vault. They had performed a patch that you can see kind of on the right-hand side, where they had a hole where that they had installed the piping system, and then they had put the patch on that Friday before. Over the weekend, they had put this lid back on that opening so that none of the neighborhood kids or anybody would get into that area. And then Monday they come back to check and see how it was. The employee climbs down into this vault and he faints. And the employer does not have a good rescue practice in place. They did call 911, but by the time the fire department got there, was able to package the employee up and get him out, he died from that inhalation hazard. So what we have to, of course, look at is what caused this inhalation hazard. Concrete is a notorious, oxidizer. And if you remember, your 5th grade science, oxidizer means it's using up the oxygen. And so as that concrete dries, it happened to use up the oxygen in the space. So in the simplest form, there wasn't adequate oxygen in the space. So had they done an air sample before they went in, they probably would have recognized, hey, our oxygen is only 12% in here. And normal oxygen is about 20.8. And of course, the bells and whistles on the meter would have went off. And somebody would have said, hey, we can't go down in here until we make sure we have adequate oxygen in that sort of stuff. But even more importantly, if you're going into a confined space, you also have to have appropriate rescue. Even if things go unruly in a confined space, if you have a good rescue program, then you can immediately pull the person out of that confined space. So it's critical to make sure that you're always doing air sampling in any confined space and have a good rescue plan for those sorts of things. We want to make sure that all of you, and of course, all of the workers, recognize all the potential hazards. We could have mechanical hazards down in a confined space. Carbon monoxide is a potential source. We've had lots of stories where there was a vehicle idling by a pit or a space like this. And even though up above, we don't see significant levels of carbon monoxide, in that space, we do. Hydrogen sulfide is another one that comes from manure, waste products, sewers. Often you'll have hydrogen sulfide in some level in those sorts of things. We also can see carbon dioxide. We had a motor burn up at one point in a confined space. This was for an actual pumping system. When that motor burn up the oil in there, instead of having high levels of carbon monoxide, which could have been the source, we actually saw high levels of carbon dioxide. Anytime you see rust inside of a tank, that's the same that we're looking at with this concrete, right? Rust is using up the oxygen. And so that's always a concern for those sorts of things. And then, of course, depending on what's in those lines, if you happen to have steam or things like that, that if released, could present an immediate danger to the employees. Those are all the sorts of things we want to make sure that people recognize. And then, of course, you could have sources from outside the space that could cause that. So I did want to share one other one. This was 2 employees that were servicing an irrigation well in Havana, Illinois. That's what it looks like inside the space. We'll presume in this particular case that they did do an air sample. They had a device. They had the opportunity to do air sampling. They didn't happen to write down what any of those results are, but we'll presume for the sake of the story that they had done air testing and it was fine, because it's very plausible that it was. But when the first employee goes in there and does some work, there's some rotting leaves and a slurry of liquid and mud down in there. And as you walk around in this area and do the work, it's not unusual for you to release some level of hydrogen sulfide. Hydrogen sulfide, immediately dangerous to life and health level, is 100 parts per million. And so that's a relatively low limit for those sorts of things. Perhaps the first person simply fainted. His friend and co-worker sees the employee go down. He immediately jumps down there to help him, and we ended up with a double fatality with the two employees who were asphyxiated by hydrogen sulfide that quite possibly initially didn't even show up on their air monitoring results. So it's critical to make sure that not only you're doing the air monitoring, have a good way to rescue, but then do regular checks. And when we talk about rescue, like the tanks we've just seen before, they make a wide variety of different tripods that can be used with the mechanical assist to quickly pull that person out. OSHA requires them to at least do a practice of that activity from a representative type of space at least once a year. The other thing that we saw at the very beginning, where they were doing work near the roadway, but anytime you're doing work on concrete, especially if you're going to be cutting it, we're concerned about the silica exposures. And it's not just the amount of dust that gets on the car and or things in the area. We're worried about the stuff that's so small it can get down into your lungs. The device you see the employee wearing, the little blue contraption, is what we call a respirable dust collector. And so it brings air in, circles it around. The stuff that would be filtered out in your nose go down to the bottom of it, and then the stuff that could actually make its way into your lungs catches on a filter at the top, and we measure those sorts of things. And so it's critical to either one, have that air monitoring done so you know what the levels are, or use what we have. It's called Table 1 of our silica standard, which spells out specific protocols. So if you're using a saw integrated with a water system that continuously feeds water to the blade, and you're using it outdoors for less than 4 hours, we don't even require you to wear respiratory protection. But if you're going to be doing it for more than 4 hours, or you're going to be doing it inside, we want to make sure, even though you're using the water, that you're wearing an appropriate respiratory protection. And we have some guides that will help employers for doing those sorts of things. Noise, as we talked about, is also a significant issue for us. If employees are exposed as a time-weighted average above 85 decibels, we want to make sure that they're included in what we call a hearing conservation program, which includes a regular audiometric test for the employees, making sure they select the right type of hearing protection for those exposures, whether it be plugs and muffs or both if it's super high levels of exposure. And then, of course, every summer, we end up trying to deal with heat as effectively as we can. This last summer, the agency actually put out a proposed standard recommending a written heat illness prevention program that addresses acclimatizing new workers, making sure that there's a clear plan of action to make sure that the people are drinking water, are being appropriately hydrated, making sure that everybody understands the signs and symptoms of heat-related illnesses, and that there's a system in place to check on workers that would also make sure that if their employee does initially start to have signs or symptoms of heat-related illnesses, that you have a plan of action to get them checked out by a medical professional, and or if something worse happens, a good plan of action for emergencies so that you can get them to the medical professional quickly. And then ultimately, everybody has an understanding of here's how our process is going to work at our workplace. And so the same thing would apply to you guys as inspectors who are out there working in a hot environment for those sorts of things. We want to make sure that you're appropriately protected as it relates to these issues. Now, obviously, I can't make you an OSHA expert in less than an hour, but if you do end up having questions, whether it be on any aspect, or you're just concerned about a workplace that you've run across in your work and want to ask questions or see, is this something we should be making a referral on? By all means, here's my direct line. And that's my email address. You can contact me and I will certainly get back to you as to OSHA's policies and or our practices or help make a referral if that's appropriate. So I think now we're good to answer any questions you guys might have.
Yes, of course. I have several in the chat. So let's
Okay.
first one here. For the 3 foot above the ladder to step off rule, can the top rungs of the ladder be present at those 3 feet, or do you require a step through straight ahead scenario?
Typically, you can have for portable ladders, it's okay to simply have the step around. If it's a permanent fixed ladder, yes, they're supposed to have a step through with a self-closing gate that they'll walk through for a fixed ladder.
Okay. Next question here. Does OSHA have oversight authority on private family farms that employ seasonal employees?
So it'll depend on whether or not they have more than 10 employees. So family farms, the Congress keeps putting in what they call an appropriations rider, which says OSHA do not spend any money on family farms with less than 10 employees. So even if they have a fatality, if we get out there and find out, oh, it's a family farm, they only had 3 employees, we would not be able to, we don't if you will, violate that appropriations rider once we become aware of it.
Is there a minimum quantity of material to not require an MSD, such as pipe dope for PVC pipe assembly?
Nope, the pipe dope would be, if it's listed as a hazardous chemical, the only exception would be is if you're using it in the same manner, in the same quantity as a normal consumer. So let's take the example of Windex, right? We happen to keep some Windex in our truck, and they say, well, I just use it to clean my windows about once every 2 weeks. We go, oh, okay, that sounds like normal consumer use. But although I have had pipe dope in the past, I don't have any right now at my house, and I'm certainly not using it once a week, or how often, you might have somebody, a typical plumber might use it. So we're going to say that's not normal consumer use, and so therefore you need to have a safety data sheet for that.
Okay. What are possible hazards when using a forklift?
Oh my goodness, there's quite a bit. The most common thing we run across is that, the speed at which it's handled and or the material that they're handling is just not always secure, right? If you just lift it up and go. And so we run into a lot of issues with that. We had a fork truck operator get struck by a train, right? There's all kinds of things where you think about where exactly it's used in the area. We have employees that sometimes get lifted up with the fork trucks, not using an appropriate, we'll say, container for the employee. They'll simply be lifted up on the forks. And then, of course, we have the same sorts of rollover issues that we have with a variety of vehicles, right? And so we want to make sure that anytime you're using it on any sort of unlevel ground, that it's appropriately used. And then, of course, the weights of the things that people may try to lift on that kind of stuff. People might use a fork truck to help lift, let's say, an engine block out of something. And so then the engine block, as they're trying to get it out, will slide off of those forks. It's not really equipped for doing that and stuff. So the types of potential hazards are very wide and significant.
Do employers have to report all fatalities from a heart attack?
So work-related fatalities are required to be reported. And so let's say the person for years has had, they've already had 2, cardiac arrests and had have had issues. And they, let's say they work for the local health department and they happen to come in at 8 o'clock that morning, and at 8:05 it happens. Then we would go, okay, that they may not, there's no evidence that it was work related. If you're a construction worker jumping in and out of excavations and end up with a heart attack some day when it's 90 degrees, we're going to think differently as far as whether or not it's a work related issue. Typically, we wait for the coroner to confirm that it was not work related. Said how, okay, it was just, his or her time for that sort of stuff. But the general expectation is the employer is going to report to us within 8 hours. And then we'll decide based on the set of facts that we're looking at, whether or not we're going to either go out and inspection or simply send what we call rapid response investigation, where we email the employer a letter, ask them to provide us an information within a week with any of their findings and or corrective actions.
Oh, just curious if you have seen/been involved in anything relating to violations occurring in kitchen spaces.
We have, and in fact, last year, I can't remember if it was maybe October, I came and presented on that topic at the conference up in Chicago. So yes, we have, and we certainly have a different set of hazards that we would address. I mean, the fall hazard, maybe getting up on the roof, is the same. Certainly, carbon monoxide is another of the same hazards, but in a different sort of situation. But machine guarding, all those sorts of issues, slip and fall hazards, are a little bit different in the kitchen. But all of those sorts of things are certainly things that we look at and will address anytime we get a complaint on it, and or heaven forbid, even worse, a severe injury.
Just a few more questions. What precautions do you recommend for health departments inspecting well pits for compliance? Should we as a state move to require the elimination of pits?
So I'm not an expert on well pits per se. So I don't have an opinion on eliminating them. But if you are going to be doing some checks of those sorts of things, the basic safety of it, making sure that you can stay in a safe place as opposed to somehow ending up in that well pit is what we'd be looking at.
Okay. Please elaborate briefly what common situation causes the hydrogen sulfide hazard you referred to a few times.
Try to keep it minimized, but all of our waste streams, as it rots, produces hydrogen sulfide. If you've ever been by a pig farm in the state of Illinois, you've smelled that smell, right? And that's part of what's being given off. So the anaerobic activity, lots of times they rotting leaves, stuff like that, down under your liquid produces hydrogen sulfide. As you say, even just walk in it, that gas can be released into the air. And because we're very sensitive as humans to that, it takes a very low level so give you an idea, OSHA's permissible exposure limit for hydrogen sulfide is 10 parts per million. We don't want anybody exposed above 10 as an average. And of course, immediately dangerous to life and health is about 100 parts per million. And because we're so sensitive to it, we want to make sure people recognize it and are protected from it. And so you'll often find it in those waste stream areas like sewer. It's even in your oil, like the oil they make ship from, there's a big tanker of oil that we get down in Louisiana, and they're shipping it through the pipeline. You can end up with hydrogen sulfide into those sorts of areas from the gases, or from the oil, from the petroleum product gassing off. So those are the sorts of things we're doing.
Who performs the voluntary OSHA inspections? They seem to be minimally effective.
So the voluntary OSHA inspections are actually performed by the Illinois On-Site Consultation, and that's done through the state of Illinois. Illinois Department of Labor is funded to do those. I actually work for the Federal Occupational Safety and Health Administration, and we are, of course, the enforcement and the ones that have the penalties. So a serious violation for us right now is about $16,500 is the starting point for those. And so we carry a rather significant penalty for a lot of the work we do.
And then just two last questions before we wrap up here. Oh, maybe three. Do employers have to report injuries if they occur as the employee is in the parking lot, or if they are inside the facility but have not clocked in?
The answer is yes. The employer, they're walking to the facility. As soon as they're no longer commuting, the OSHA term for do you have to report it is, are you commuting? So once you parked in the parking lot, you take one step out, slip on the ice in the parking lot, If it's the company-owned parking lot sort of thing that you're stepping out of to come into work, then yes, that's all part of what we consider the work activity.
What are some precautions that residential lead inspectors take? Oh, is it residential lead or residential lead? I
No
apologize.
lead.
Okay.
We could spend the next hour on it, but we'll go through the 6 main things. One, they're supposed to do initial monitoring for what the lead levels are. 2, they got to select the appropriate personal protective equipment to protect them from those hazards. We want to make sure they have adequate training. We want to make sure they have adequate hygiene, place to wash off as they're, as they're liable to have contact with lead, so they're not putting it into their cars or bringing it home to their kids. And then finally, we want to make sure that employees who knowingly have exposure to lead get a blood lead and zinc protoporphyrin test so that we know what kind of levels we're seeing from that activity. And so I don't know if that was what they were answering to, or they're at a different question. But if it was lead, those are the big issues that we want to make sure are addressed.
And then our final question we have is, this may be random, but how do cruise ships discard their wastewater?
That gets outside of OSHA's jurisdiction, so I cannot say exactly how they get rid of their wastewater, because we cover employee safety, and you've just got outside of my realm, and that'd be a better question for an EPA person.
Okay. All right. Well, Brian, thank you so much for joining us for today. Thank you everyone for your questions. Let's see. Oh, I thought there was another question in the chat. No, just everyone saying thank you. Lots of thank you, saying the presentation was very interesting and informative. So with that being said, I think we can just slide right into our next presenter. Again, Brian, thank you so much. Hope to see you next time.
All right, thank you.
All right, so James, if you're online.
Yep. Hello, I'm here.
All right, hi.
Hi, how are you?
I'm good. How are you?
And hello, everybody. So I can start sharing my screen here.
Yes, you're good to go.
Okay. And all right. Everybody, it's showing the screen of the slides, right? Not the one with all the notes and everything.
It shows the one with the notes.
Okay. I think I can switch it here. That better?
Yes, excellent.
All right. Hello, everybody. My name is James Meese, and I work with the Rural Community Assistance Program, or RCAP. We're a national non-for-profit that helps rural communities with water and wastewater issues. When we talk about rural, what we mean is 10,000 or under. What we do is we help them with technical, managerial, and financial assistance. Technical being that we have wastewater operators, and water operators. We work on them hand-on, one-on-one. We also work with community members, board members, do trainings. We do things such as rate studies, have access to grant funding. But on the other side, what we've started in the last 5 years is we've been working with individual homeowners on our private well and septic program. What that is we'll actually go out and do private well assessments at no cost to individuals. We'll look at their well. We'll do testing for them. We test for metals, bacteria, and any sort of contaminants, nitrates, arsenic, that type of thing. And we've also kind of moved into private septic in the last couple of years. We are starting slowly to roll out our private septic assessments. But one of the things that I was asked kind of to speak about today is kind of the basics of private septic systems in households. So we're going to go through a couple different modules here. This presentation itself was developed by NORA, or the National On-Site Wastewater Recycling Association, in conjunction with RCAP. So that's kind of their mission statement. I attended a 3-day training in Massachusetts on this 2 years ago on what this training is and how to deliver it. Again, that's who we are. We are RCAP. I am in the Great Lakes region. I am the state manager for Illinois, so I do have me and 4 other employees underneath me, but we do help all regions in all 50 states. This is our disclaimer acknowledgement that this was provided for with the US EPA. So moving into it, we're going to talk about, module 1 here is the overview of the on-site wastewater systems. We'll also have some tips and tricks for individuals. So our learning objectives for this module is to learn to understand the function of on-site wastewater treatment systems and to gain knowledge about the various types of treatment and dispersal methods. There is a guide for this on the NORA website, and I also have physical copies. I will put in my contact information at the end of the chat at this. So if you think, if you'd like a copy of this, let me know. I have no issue sending you one. Also, if there's anything that you think RCAP can assist you with, either with those well assessments or questions about septic, or if you have a community that you think we can reach out and help, feel free. We are here to help. That is our purpose. So this doing an overview. All wastewater treatment systems, whether on-site or at the municipal scale, have common features. The wastewater is collected in sewer pipes. Solids are separated from the liquid, often called the primary treatment or the municipal scale. Contaminants that are dissolved in the water are mostly removed by biodegradation. Pathogens are destroyed, and the treated water is returned to the water on the hydrological cycle. So kind of, the basics here. Septic systems are just kind of a smaller version of what they use on the municipal scale. I mean, there's a little bit of differences, but a lot of the basics are the same. So kind of, thinking about how big is the water cycle, especially in a septic system. Your water cycle is going to be slightly different than on a much larger one, but it's all kind of the same goal, because our ultimate goal here is to protect public and environmental health. We accomplish this goal by ensuring that the waste component we put in the water do not create a negative impact on the next person who uses the water. This time it takes for the water to be used, again, depends on your location within the water cycle. If your water well is close to your neighbor's septic system, the water cycle may be fairly small. The smallest water cycle is on the International Space Station, where all of the water is continuously recycled. So, if you kind of think about that, you're continuously recycling the water. But, if you have that kind of smaller system, if your well or you have several septics and wells relatively close to each other, then obviously that water cycle is going to be smaller, because as that water is returned to the ground from the septic, it's seeping in into the well. So you want to make sure that you are doing everything you possibly can to make sure that's cleaned and everything on there. So talking about wastewater treatment overview. For on-site wastewater treatment systems, we think about treatment in 2 basic phases: pre-treatment and final treatment. Pre-treatment prepares the wastewater for first treatment in the soil. It was stated many years ago that the primary purpose of the septic tank is to protect the drain field. This statement is basically true, but understand the other benefits provided by the septic tank. If the ability of the soil is limited to the ability to provide final treatment, the advanced pretreatment can be employed to reduce the wastewater strength before it is applied to the soil. We use the term strength to indicate the concentration of contaminant relative to average conditions. We expect that the rural convenience store that serves fountain drinks and greasy foods would have a greater concentration of organic compounds, sugars, and fats and stuff in wastewater. This wastewater would be considered high strength relative to organics. So that's kind of looking at it, we have so do basic treatments here, pre-treatment and advanced pre-treatment. What do we do to treat those? How do we go about doing it? Then talk about final treatment for on-site wastewater treatment systems, that use the soil. For final dispersal, the soil provides final treatment. There are billions of hungry microorganisms in the soil that like our wastewater. They break down many of the complex compounds into simpler, less toxic forms, such as carbon dioxide and water. So again, once that goes into the soil, those natural organisms, that natural biology kind of starts to take place and begins breaking all those down. So talking about a conventional treatment train, The word conventional is often used to describe an on-site wastewater treatment system that serves a single residence. The wastewater flowing through the system by gravity, and the system consists of a collection network, a septic tank, and a soil treatment area. So again, I mean, you'll have your house, you have your septic tank, and then you'll have your drain field and your soil treatment area where that water is being treated. And those microorganisms are starting to kind of help break it down once it comes out of that septic tank, where some treatment is also taking place. Talking about wastewater treatment, it begins in house collection. I always like this graph. It kind of shows how much water is used by in a household. So, you know, a shower would use 20%, your toilet in your bathroom 24, clothes washer 16, faucets 20, leaks 13%, or other 5.3. We also talk about black water. That's going to be toilets, kitchen sinks, and dishwashers. Your gray water, that's going to be things that are dirty, but they're not quite the same as the black water. There's not as many contaminants in there, and that's going to be your laundry and your shower. Wastewater collection is the first step. The drain waste vent system in your house provides the service. Wastewater is then carried out of the house by the building sewer that conveys the wastewater to the next component of your treatment system. What are the ways we generate wastewater? Baths, we launder our clothes, we wash dishes, and of course, we dispose of the byproducts of our metabolism. We often hear the term black water, gray water. The terms only become important if we want to think about water reuse. Black water is from the toilet, kitchen sink, and dishwasher. The water contains pathogens and our heaviest concentration of other waste products. Gray water will contain more soaps and detergents. So again, kind of looking at, kind of thinking about those different types of water and what we want to think about when we think about reuse in the system. So we're going to talk about separating the solids from the water. For most on-site wastewater treatment systems, the next component is the liquid-solid separation. Many jurisdictions require two compartment septic tanks. The walls between the two compartments reduce the turbulence, and that occurs when there is a sudden inrush of water, such as where the laundry machine discharges water into the system. The reduction of this turbulence improves the settability of the solids. That's why we always talk about, if you do have a septic tank, if you're living on one, especially if you're encountering new homeowners who've never used one, you want to recommend that you do your laundry throughout the week. I know a lot of people like to do it on Sunday, or Monday they have a set day that this is laundry day. But for septics, that doesn't work because that increases that turbulence, especially if you're doing it over and over again over time. You're getting an injection of that gray water into the septic repeatedly, and it's not allowing for things to settle. So as opposed to if you do it a tad bit over a little bit of time, then it gets a little better. If you're familiar with the septic system's rules in the jurisdiction that you're in right now, you might take a moment to discuss. So you might want to, just think about how that works and how the flow rate of the source for the wastewater kind of, affects that septic system. Talking about inlets and outlet baffles. The liquid enters the tank through the inlet baffle. This baffle forces the water downward to encourage the settling of solids that are more dense than water. Solids that are less dense than water will rise. Solids that sink become sludge at the bottom of the tank. Products that float become the scum layer. So again, thinking about your septic system there, we have that diagram there. You eventually kind of separate it into the three layers where it comes out of that baffle, and then it kind of separates. So you have the effluent in the middle. The bottom, those things that sink, those eventually become sludge, and the top eventually becomes scum. And that separation becomes really important because that's helping you separate out the things, the negative things that you have within that septic tank. So, a good septic tank, when it's doing its purpose, is exactly that. It's helping separate out those solids into that scum and sludge layer. So we have that effluent that can be treated, through the septic system. If the system is operating properly, the layer of water between the sludge layer and the scum layer will have the lowest solid content. The outlet baffle is placed so that only water from this clarified zone is allowed to leave the tank. So again, we had those two chambers here. In the first chamber, we're doing our separation. Then we're letting that effluent flow, which has the lowest contaminant level, into our second chamber, which is then going out of the outer baffle, going up into the other baffle, then out into the treatment field where the soils will kind of start treating that effluent and getting out whatever remaining contaminants might be in there. So solids retained in the septic tank. As we described in the previous slide, the heavier solids will sink and form a sludge layer, and the less dense solids will rise and form a scum layer. These products will degrade slowly in the septic tank if they are biodegradable under anaerobic conditions. This is a good opportunity to talk about fats, oils, and greases that we want to think about that are going into those septic tanks as well. Fats are from animal sources, oils are from plant sources, and greases are from petroleum-based and come from skincare products. So I always like to point that one out because a lot of times if you hear grease, you're thinking about, grease from cooking, bacon grease or hamburger grease. Those are considered fats when we talk about in the world of septic tanks. And it's purely because those are from animal sources. Greases are going to be more things like those soaps that you put on your body, lotions, those type of things, and those skincare products. And again, you want to avoid putting, obviously, your fats and your animal sources and your oils from your plant sources into the septic tank. Those are harder to break down. They're not something that's naturally occurring. Those greases, again, you want to kind of reduce the amount of greasings you have. So the greases that you have in there with your petroleum skincare products. So you want to maybe look at more natural soaps. I've always been told that bar soaps are a little bit better for this than the body washes, that type of thing. So again, if you're talking to individuals on a septic system, you want to inform them that they want to think about their bathing products because again, everything that they wash down into that drain is going into that tank, and it can have an effect on the system, and it can have effect on those microorganisms that are in there to help break down everything. We then have our clarified layer. The entrance to the outlet baffle is placed in the clarified zone. Some septic tanks have an additional screen built into the outlet baffle. Some don't, kind of depends on the age and the exact model that you have. The effluent screen provides an extra level of protection to prevent smaller solids from entering the soil treatment area. And we'll talk about more about those screens kind of here, but that's a big thing you want to think about is that that is going out. And if you do have one of those screens, you're preventing anything that could have floated through that effluent layer and gotten in there that wasn't fully separated into the scum or sludge level. As previously mentioned, some homes and businesses can produce wastewater that is too strong for the receiving soil. In these cases, additional pretreatment is added to the treatment system to reduce the strength. You do have some of those treatment things that those pretreatments, if you are having some of those, a little bit more disinfection or a little bit more into the nutrient removal. As opposed to just kind of do it naturally. So talked about organic strength reduction, often called ATUs. Aerobic treatment units provide ideal conditions for aerobic oxygen-loving bacteria to break down organic compounds. Air, which contains about 21% oxygen, is bubbled through the water, allowing oxygen to dissolve into the water. The dissolved oxygen supports bacterial activity. As organic compounds are oxidized, these compounds are reduced to simpler forms such as carbon dioxide and water. The bacteria have plenty of food and oxygen and thus reproduce at a rapid rate. Much of all the sludge at the bottom of the tank is dead bacteria cells and compounds that are not biodegradable. Because all living cells need nutrients, some nutrients are are taken out of the wastewater. However, if the sludge is not pumped out of the ATUs on a frequent basis, some of the nutrients will recycle back into the water as dead cells and degraded. So again, that's kind of, we talk about our importance of pumping septic tanks a lot, and we'll talk about that more later. But one of your main issues there is that sludge is not going to break down over a period of time. So you want to make sure that you're doing your best to get that sludge out of that septic tank and broken down so it does not have an effect on your microorganisms in there. I'm talking about organic strength reduction. Media filters provide the same aerobic treatment as an ATU. The primary difference is that the bacterial are attached to the media and the wastewater trickles through the media. As the water trickles through the media, oxygen and organic compounds diffuse from the water to the bacteria. The system has the advantage of not needing an air pump to aerate the water. The disadvantage is the biosolid sludge can accumulate in the media. Just as ATUs need to have the sludge removed from the bottom of the tank, media filters may need occasional media cleaning replacement to keep the system operating properly. So again, looking at constructed wetlands. Constructed wetlands are another means of providing advanced pre-treatment. Wetland plants that can grow in saturated conditions, grow in the media that allows water to flow through just beneath or just above the surface. Because the water is at or near the surface, oxygen can easily diffuse into the solution, creating aerobic conditions. The plant roots provide a good support for beneficial bacteria to oxidize organic compounds. Aerobic treatment units are common methods of reducing organic strength, but they are not the only method. Media filters are a second common means of reducing organic strength. We suggest that you cover aerobic treatment units in media filters as an advanced pre-treatment devices. If you feel that no one in your community has a constructed wetland, then obviously this isn't going to be super relevant to them, but we do see them every now and then. Disinfection in general, in general terms, disinfection means that the destruction of pathogens, which is different from sterilization, the destruction of all microorganisms. Disinfection is provided when there is a great risk of human contact before the natural die-off of pathogens occur. Such cases include spray dispersal systems, septic systems that are adjacent to lakes, and systems in sandy soils with shallow groundwater. E. coli is used as an indicator of the potential for pathogens. The assumption is that if no E. coli are present, then the risk of pathogens is very low. Kind of, that's pretty basic there. No E. coli, which is kind of the basic moniker for everything. Then we want to look at our tests there. They do have tablet feeders as well. Chlorine is generally the go-to compound for disinfection. I mean, that's kind of across the board for everything, water and wastewater, that chlorine is going to be used for the disinfection. A common means of adding chlorine to an on-site wastewater treatment system is to install a tablet feeder. So you would have that, the tablet feeder in there. You're adding those small chlorine tablets as needed. 3-inch diameter calcium hypochlorite tablets are placed in the feeder where the chlorine can dissolve in the water. Additional tablets must be added as the old tablets dissolve. So, kind of almost like a swimming pool has these as well, would be kind of your best example. You're going to have those chlorine tablets and you're going to add them as they erode over time. You're going to replace them to make sure that chlorine is getting into the water and that the disinfection is allowed to happen. We also have ultraviolet light. Ultraviolet light, or UV, is a second common method of providing a disinfection on-site wastewater treatment systems. A UV light produces a light with the wavelength of approximately 200 to 300 nanometers. The optimum germicidal value is 254 nms. This light wave damages the bacteria's DNA, preventing them from reproducing. So again, this is another method for disinfection that you may have too, using one of these lights to damage those bacteria. So talk about moving between treatment components. Water flows downhill, and gravity is the least expensive way to move wastewater. Not every home site has sloping ground, and sometimes the best soil for the final treatment is at a higher location. Lift pumps are used to move water uphill. A second application for pumps is to provide the water pressure for pressurized distribution systems, which will be discussed in a few minutes. So again, I mean, talking about, if you're going to be moving between it, you want to use gravity is going to be your best bet. Gravity doesn't, blow up. Gravity doesn't have pumps that go out. Gravity, if you lose power, you're not going to have a backup there. But again, we do understand that if it is not possible for some homeowners or some sites that you do see, that potentially using those pumps and to be able to move that water with those lift stations is something that is a possibility. So pumps, pump tanks, and controls. A pump requires a pump tank and pump controls. The pump tank allows for the accumulation of effluent so that the pump does not so the pumps do not have to operate all the time. So again, I mean, it allows for to take a break, because again, you'll run your pump out or it'll blow up if you keep it going constantly. Typically, the tank is sized to hold a volume equivalent to 2 days of water usage. The volume allows for the time needed to repair the pump system in case of failure. Most pump systems have a high water alarm to notify the owner if the pump has failed. So again, we do, we'll see these, and if you do have a pump, having that alarm is pretty vital. Because it will allow the homeowner or anyone on site to know that water is getting too high, and that your septic system is starting to fail because you're having a little bit of an overflow because that pump has failed. Talking about pump tanks, the pump and the control. The controls are maintenance itself and must be accessible from the surface. All items associated with a pump system have a maintenance requirement. As such, please reinforce that pump systems must be accessible for maintenance and repairs. You would be shocked the amount of people who, if they don't like the pump or they try to bury the pump, or they put it underground, or basically they make sure it's not accessible because they don't think about it. We see this as a larger problem, especially septics in general, where we understand they try to hide them, but through trying to hide them, they sometimes eliminate the accessibility of them, which is obviously a problem when they start to fail. If everything runs, great and perfectly all the time, then it's not an issue. But once things start to go south, if you do need to, pump the septic system and get in there and clean it out, or you have any issues, not having that accessibility has created a much larger problem. You already had a big issue if your septic is needing maintenance and everything, and now you've created an even bigger problem because we have to sometimes find it. I've found some homeowners don't even know where their septic systems are, which is baffling to me. And then two, once it is found, we have to figure out how to access it. The typical wastewater lift used for on-site wastewater treatment is a submersible pump, and it's less than 1 horsepower. This means that they do not need to be primed, and there's a minimum electric power consumed by the pump system itself. So again, we're talking a very small pump if we do have one in there. And that does help them last a little bit longer too. So we have our controls, we have our floats and timers. The controls should be in the weatherproof control panel. Again, it's pretty obvious, but you'd be shocked the amount of people who get that confused. Most pump systems have 1 or more floats to activate the pump and to activate the alarm. The electric leads from the floats should terminate into the control panel. Although not usually required, it is strongly recommended that pump control systems include a pump timer and the event counter to provide information about the operation of the pump, so you know how long that pump's been running. If you have a timer on there and and it looks like it's been running constantly, you kind of have an issue within that. After pre-treatment, the effluent moves to the soil-based final treatment. The soil is the ultimate wastewater treatment system. Again, this is where the majority of those contaminants are going to be broken down. Municipal and on-site scale systems are or engineered devices to try to mimic the soil. However, the soil must be able to pass the water. The first step in determining the sustainability of a soil for final treatment is to determine the rate by which the water can move through the soil. Most locations no longer use the percolatin test to make this determination. Rather, trained soil evaluators look at the texture, structure, and depth of the soil to determine its ability to move the water and provide final treatment. So again, if you have that soil and you're getting worried about it, or you're worried that it's not going to be able to move through, being able to having someone or being able to do an assessment to make sure that water can move through there, and it's also not moving too quickly, it's moving at the proper rate, is vital. Again, the soil is going to be a complex media. The soil supports microorganisms that can degrade organic compounds, contains inorganic compounds that can bind with phosphorus, has porosity so water and air can move, and allows for the plant uptake of other nutrients. So again, kind of looking at that, a suitable soil allows for biodegradation, nutrient conversion, binding with minerals, plant uptake, and deep percolation of the water. So that's kind of what we're looking for. We're looking for that's those drain fields that the effluent's going to go into eventually and go through the soil. This would be your perfect mix. Applying effluent to soil. Soil-based wastewater treatment systems use trenches or other types of excavations to place effluent in the subsurface soil. A trench refers to an excavation that is 2 to 3 feet wide and is partially backfilled with a media that provides porosity or an open void that allows for the storage of effluent. This storage is needed for times when the inflow of water to the trench is greater than the outflow of infiltration into the soil. So again, you have your trench-based dispersal there, and you want to make sure that everything is being dispersed properly. Dispersal into the soil. By placing the effluent into the subsurface environment, we are putting the barrier between us and our waste for public health, and are placing our waste in a location where renovation can take place, thus protecting environmental health. Again, we are basically trying to make sure that we're not going to make anybody sick by getting rid of our wastewater. We want to make sure it's treated as properly as you can within the septic tank. Those solids are separated, and once it goes into the soil, we want to make sure it's going into somewhere where it can actually be properly broken down and eventually be used for reuse or get back into the water system. What we don't want is basically to be dumping those chemicals or those solids or any sort of contaminants back into the soil, and they're just going straight through into the water cycle without anything happening or without any microorganisms or anything breaking them down. That is how individuals can get sick. So common dispersal methods. Again, you have your trench cross section here. The common style of applying effluent to the soil includes subsurface gravity, subsurface pressurized above the surface spray distribution, and systems that provide both additional treatment and dispersal in subsurfaces. Here, you have kind of your conventional septic systems. Most on-site or wastewater treatment systems are considered conventional. This means that water moves between components and through the soil treatment area by gravity. These are trench-based systems where effluent enters one of the trenches and moves to the opposite end. Effluent is continually infiltrating along the trench length, and so more infiltrating takes place near the beginning of the trench. As more influent enters the soil, there is an increased accumulation of biological materials or biomat that limits the infiltration rate. At the biomat forms and the infiltration rate is reduced water and can move further down the trench for rapid infiltration. Because water can only enter the trench from one location, that location does not get an opportunity to dry out. So again, throughout Illinois, doing our inspections and our assessments, this is what I have seen most commonly. Every now and then you will see an anomaly, but I think this is what the majority of homeowners have. You do also have low pressure pipe systems. A low pressure pipe system is a solution to the poor distribution found in the conventional system. The system still has a trench system and media that provides more storage in the trench. A pipe, typically 1 to 1.5 inch diameter PVC, is placed in the trench. This pipe has small perforations, 3/16 to an inch is typical, spaced every 60 inches. These perforations or orifices distribute water along the entire length of the trench. This is a pressurized system, so a pump or a dosing siphon is needed to provide the pressurization. There are drip distribution systems for some sites with limiting soil conditions. So again, these are used if you have limited soil, if you're in a smaller area, or that soil is not going to work as well. A distribution system to use drip irrigation technology may be as a solution. With this technology, some regulatory jurisdictions will allow less than suitable soils to be used for final treatment. The drip system provides a precise application to the effluent to the soil. A drip system requires filters to be installed just after the pumps. This technology requires maintenance, so a little bit more work than your traditional trench system. You're going to have a little bit more maintenance on it, but it is an option if you're running into issues with those soils. Spray fields are also an option. Spray irrigation is another means of allowing a less than suitable soil to be used for the final treatment and dispersal. Not everyone allows these. It's all kind of dependent on where you are. Pop-up sprayers are commonly used at a location that allows spray dispersal. Most require that the effluent be disinfected. The spray field is fenced, and the spraying takes place at night. Combined treatment and dispersal. Combined treatment and dispersal systems provide additional treatment in the subsurface environment, often used in low permeability soils where the addition of organic matter and solids from the wastewater could further reduce the permeability. These systems help extend the life of the infiltrative surface. Sandline trenched. Sandline trenches provide a very similar treatment mechanism as media filter. Effluent is distributed along the length of the trench. The effluent trickles through the media under aerobic conditions. This provides additional organic compound removal and some nutrient transformation and additional solid filtration. You also have mound systems. Mound systems were the original combined treatment dispersal system in order to get additional separation from a limiting layer, groundwater, bedrock, or heavy clay. Mound and sands are raised. The effluent is allowed to trickle through the media. The mounds are covered with native soils and planted in native vegetation. Non-soil-based dispersal. There are non-soil-based dispersal systems that return effluent back into the water cycle. Again, not a lot of these, but we do see them every now and then. You have your lagoon system here. A few regulatory jurisdictions allow lagoons for residential on-site treatment systems. Lagoons have a long retention time, allowing for slow treatment effluent. The typical practice is to hold the effluent during the dry season and then release the effluent during the wet season when there is plenty of dilution. At locations that allow lagoons, it is typical for the regulatory agency to require the homeowners to have 5 or more acres to provide a significant buffer from the neighbors. So again, not super common, but if a homeowner is using a lagoon system, they need to have a significant amount of space for that. So again, evaporation beds. I haven't actually ever seen one of these in Illinois. Not really a big one. Direct discharge, again, we don't see a lot of this either. We like to see some treatment. So that is this section, and we will move on to section 2 here. Right.
This one also shows the notes as well.
Yeah, there we go. Sorry, I had to find my mouse to swap it. All right. So this is overview and management. This one's a little bit different, but we're going to be looking at kind of, the best way to manage those septic systems. We kind of know how they work now and what the basics are from what we had just gone through. So this is more on the sides of the risks with septic systems and kind of what we have with them. So gases produced are flammable and hazards to humans at high levels. So again, if you're having those gases kind of leak out, those can be hazardous. They can be flammable. Wastewater contains pathogens, which makes people sick. So if you have a leaking septic tank, this becomes a major issue, especially if it, obviously we never want the septic tank near the well, but if it is near, if it, if it shares where that groundwater is or can near it, or it's a possibility that it's leaking and contaminating your groundwater and your well water, that is one of the bigger issues that we have there. Tanks and systems can contain 4 or more feet of water, which child, pets, and even adults could potentially drown in. So again, being aware that you have your seals on, that your lids are on, that septic tank is covered, that no one can mess with it or fall into it. And tanks and other components could collapse if driven over with heavy equipment. So especially if it's in a farm field or you're doing work on your property, make sure you're not driving over that septic system with any major heavy equipment, because we want to avoid a collapse. So safety rules protect, family and pets. Never enter the septic tank. Even if you think you're trying to have a small issue, leave that to a professional. Do not smoke or have a fire near the septic tank openings. Again, if those gases are flammable and can be explosive, so obviously having open flames near them is increasing your risk of that. If wastewater is on the surface, the issue must be corrected. So again, if you have a backup, if that water is, backing up into your system or on the surface of the water, you need to deal with that, immediately, because again, that wastewater could be leaking into your water system, your ground system. It is no longer being contained within the septic system. Do not use electrical tools near the water or the wet ground, as it could cause shock or explosion. Keep vehicles and heavy other equipment off of the septic system. Again, don't drive over it. We don't want to collapse. We don't want to collapse that soil either. We want to make sure that soil is staying loose to allow that effluent to flow through. So we're not even talking about directly on the septic system. We're really talking about, your trench field as well. And assure all lids are secure and in place to prevent entry at all times. Again, we want to avoid anything falling into the septic system. Children being number one, animals, pets, but even wild animals as well. If they're going in there, if they think there's water in there, if you get one in there, then obviously it's not going to break down and it's going to cause much larger bacterial issues in the future. Hiring, you want to hire qualified professionals to clean out tanks, service advanced treatment systems, evaluate the soil treatment area, kind of have what you talked about earlier, make repairs, sample the system, and report results to permitting authority if required. But again, for homeowners especially, what we want to do is promote to them that do not do this work yourself. You want to make sure that the professionals are the ones doing it. Talk about septic tank maintenance, frequency of plumbing. All septic tanks must be periodically pumped, cleaned to remove floating scum and sludge that accumulate. If either floating scum or sludge is allowed to enter the soil treatment system, it will cause expensive and possible irreparable damage. The pumping frequency depends on its size, use, and operation condition. Septic tanks for a single-family home are typically cleaned every 2 to 5 years, but be sure to check with your jurisdiction about when it may be required or needed based on your unique system and uses. So yeah, 2 to 5 years is recommended, and it's definitely what we need. There seems to be a mentality out there from homeowners I've dealt with that this is more of a recommendation than and I kind of try to tell them, no, you need to have at least someone come and check it every year. I've had some, I've lived here 10, 15 years. We've never had a pump. It's never been an issue. You're like, well, no, it's an issue that you're not seeing yet. There could be issues occurring. So just really making sure if you're talking to homeowners or dealing with anybody on the septic system to make sure that they know that we really need those things really need to be checked out, rather frequently as opposed to when they feel that they need to be done. Talk about septic tank maintenance continued. Proper pumping will remove all scum and sludge from the septic tanks and lift tanks. This requires pumping, flushing, and back flushing liquid contents back and forth between the truck's tank and the septic tank through the manhole several times. This process breaks all the scum and sludge in the tank, allowing all solids to be removed by the truck's suction line. Some contractors use special tools other than back flushing to liquefy the solids. Floating scum left on the tank after pumping may plug up baffles or allow solids to enter the soil treatment areas when the tank refills. Pumping will leave a black film on the tank walls and a small amount of liquid on the tank floor. This contains millions of bacteria to quickly regenerate the bacterial activity following the pumping. The material removed from the tank is called septage and must be managed in accordance with the state and federal regulations. So again, make sure, especially on that last one, the state and federal regulations. I was at an individual's house 3 weeks ago who said that in the past they had not pumped, but if they needed to, that their father is the one who did it. Their father was not a septic tank professional. He just happened to have, a vac truck, and you're like, well, really need to have a professional there, so we make sure everything's being followed properly. We're putting the septic system back in the place that it was found, and most importantly, that we're taking that material that was taken out of the septic tank and being disposed of it properly. So tank cleaning with correct access. When the tank is pumped, be sure to have the contractor check for leaks and make sure the baffles are in place and function properly. Again, making sure that everything is put in there, that there are no leaks. That's going to be the most important thing, because septic tank leaks affect groundwater affects drinking water affects public health. So, it's kind of a cycle there, but if those leaks are occurring, it can have a real problem if, your well and your septic tank, there's always levels for contamination there. Pumping a tank through the inspection pipes is a bad idea and will often leave solids in the tank and possibly damage baffles. Insist that the tank be pumped through the manhole. If the tank has one, most tanks have manholes, but they may be covered with soil. So again, that goes back to what we were talking about earlier, making sure that you have access to those, making sure you know where your septic tank is, making sure it's not buried. So, kind of keeping up with that so we make sure that we don't have any issues there. Earlier I talked about those effluent screens. So if you do have one of those, you want to make sure those are being cleaned. If the septic tank has an effluent screen on the outlet baffle, it should be cleaned periodically according to screen size systems used in conditions when clean. The screen can be cleaned by the owner or a septic tank professional, but always a manner prescribed by the manufacturer or suggested by the installer. Be sure to wear protective gloves, wash hands and clothing thoroughly, return the rinse water and contents to the on-site septic if it is being pumped at the same time, or to a remote area where the people and animals will not come into contact with it. So there, we have an individual cleaning that screen. Your cleaning report. After your system is serviced, a septic system professional should give you a report similar to when you get your oil changed. It should indicate how full your tank was, and indicated by sludge and scum, which can be used to schedule your next service visit. Any problems or future repairs needed should be noted, including any signs of leakage into the tank, safety concerns, and or damaged components. So again, if you're talking to homeowners who are dealing with septic, or if you are one, if you do have that cleaned, make sure that you have, you're given that report. One, it will allow you to understand how much you need how much is needed for that cleaning and what is needed in the future. And two, it will really give you the diagnostics of what you're dealing with to make sure you have, anything there. Additives are not needed. There's no quick fix or substitute for proper operation and regular maintenance. There's no scientific or technical data indicating that additives are required. Do not use starters, feeders, cleaners, or other additives. Many of these additives suggest they work via enzyme or bacterial action, but your system has all this in that is needed naturally. So again, don't add anything to it. We know that there are products out there on the market, Ridex kind of being one of them, and other kind of more popular starters as well. But they're not needed, and if anything, they'll cause more damage because they can damage those natural bacteria within the septic system. You have everything you need. The septic system is working. If it's working properly, everything is needed there. So nothing needs to be added. Nothing needs to be purchased. Advanced pre-treatment general maintenance. You want to evaluate that every 6 months annually. A sample of the effluent is collected and either a visual laboratory test is performed. You want to permit it to a permitting authority, and you want to check the soil treatment area or discharge. So typical maintenance for all soil treatment areas. During service visits, the service providers should look at the servicing effluent signs or traffic over the system, excess of surface water collecting over the system, and if there is any inappropriate vegetation growing over the system. The proper property owner can keep an eye out for these too. So again, when you have that service professional come over, have them go ahead and look at your surface area to make sure you don't have any of those telltale signs of any sort of issues happening. Typical maintenance with gravity distribution systems. If available, the distribution box in the system should be opened, cleaned out if needed, and adjusted to ensure the equal flow of the various lines. I mean, we have these gravity boxes, but we do know that in soil, things can kind of naturally occur over time, natural movement, and that can affect how that is going. Typical maintenance of pressure soil treatment systems. If accessible, the distribution system should be evaluated for uniform effluent application across the soil treatment area. The lateral may be needed to be flush and remove any accumulated biosolids. Typical maintenance and pumps and controls. During the maintenance, confirm that the pump is working and set appropriately. It's accessible, it's elevated, that your alarm works, that the tank with the pump may need cleaning if sludge is present, and recording of runtime cycles or pumps when available, and determining those flows to make sure that pump isn't running constantly, making sure it is being shut off, because again, that is the easiest way to blow out your pump there as well. And then also making sure your alarms are working, everything is corrected, everything is on there, because again, those alarms are vital that if you do have a backup or distribution. Record keeping. Some jurisdictions require that the report must be submitted when services performed for the system. It is wise to keep records of your system's design. So again, making sure that you have those records. Also making sure you just keep a copy. If you ever go to sell the home, it is nice to be able to hand over to the next homeowner so they're aware of kind of what's happened with the septic system and any sort of future maintenance that might come up. Also, this kind of knowing your pumping schedule. If they have around about the same amount of family, or they, or in the same area, then they're kind of aware of it, where you've at and what you've been doing. Private wells, have them tested. You want to look for chloroform and bacteria. You want to do that every year. Nitrates every other year. Arsenic at least once. Lead at least once. And manganese before baby drinks the water. I would say same thing with nitrate on that as well. Making sure that you're testing for that nitrate, especially if there's going to be any young children, especially infants within the house. And again, this is a service that RCAP provides for homeowners. So if you have a homeowner that you think may have an issue with their drinking water affected from their septic tank, please let us know. We can come out and we will give them the test and everything they need. So with that is the conclusion of Module 2. So I think with that, we can kind of wrap up our presentation. I don't know if there are any questions. If not, thank you everyone, and RCAP is always here to help.
Thank you so much, James. It looks like there was one question here. On aeration septic systems, I have a company servicing it twice per year. What are some early signs that I need to know when it needs to be pumped? I'm not always able to be present when the company puts more chlorine tablets in the system.
I would say just kind of looking for your basic signs there. That, making sure that there's no water on top of it with the aeration. But really, I would go with the company's recommendations. They are the ones that are being kind of they'll have a recommendation for they'll be the ones that have recommendation for when they think it kind of needs to be pumped, especially if they're the ones dealing with it on a regular basis.
Excellent. And then, oh, another Q&A here. Are there some solids we should not be putting down the drain, i.e. banana peels, cabbage leaves, etc.?
Yeah, all of those. The worst thing that you can do for a septic system is have a garbage disposal. Those are all things that should not be going down there. So if you're attached to a septic system, do not use your garbage disposal if you have one. You basically want to be just putting down that natural gray water and the black water, but anything beyond that, any sort of solids of that area, you don't want to be using. Even animal waste as well. If you have pets that may have, an accident in the house, you want to avoid some of that animal waste too, because what they might have in their system is a little bit different than ours, and those microorganisms might not react as the same. So.
Okay, excellent. Does anyone else have any other questions? Okay. I do not see anything at the time, but James,
Right.
thank you so much for joining us. Really appreciate having you here. For everyone else, I'm going to give us just a slight mini break for people to take like a water break, bathroom break. I will start back up with the recording right at 3 o'clock for our final presenter for the series. Thank you.
All right. Yep, and I just entered my email in the chat, so if anyone has any follow-up questions or anything that's needed, feel free to reach out to me.
Excellent. Thank you so much.
Thank you.
Mhm. All right, everyone. I wanted to kind of bring us back from that small little break. I wanted to go ahead and introduce our next speaker for our final day of the virtual spring conference. We have Dendra Best is joining us. Now, Dendra, I'm going to turn it over directly to you. Just want to make sure you're able to share your slides and everything.
Sure, let's give it a try.
Excellent.
Okay, can you see that?
Yes, I can.
Oh, great. I do apologize, everyone. We've had a pretty serious family medical emergency this week. So if any of this gets screwed up, you can blame it on me and the local hospital system, but that I shouldn't say. But anyway, okay, let's get started here. This is the topic that we're going to be talking about today. And this is me, Dendra Best. I'm the Director of Education, and I'm also the CFO for our nonprofit organization. And it's been really interesting because some of the things that I had in my presentation today just actually came roaring back into being relevant because of my husband's hospitalization. And that is something that I will touch on briefly as we go through here. We are a public and a professional training nonprofit. We were founded back in and a long time ago, 2003, under the auspices of the Joyce Foundation, who at the time, one of their prime areas of interest was protecting water sources in the Great Lakes Basin. You may remember back in the early 2000s, there were serious proposals to pipe water from the Great Lakes down to the desert Southwest states. And obviously, there's an international border there, and Canada and the United States and the communities that surrounded the Great Lakes became quite concerned. At the time, too, we were based pretty much solely in the probably in the northern Michigan sector. And the reason we were was at that time, there was actually very little acceptance of decentralized and on-site wastewater. It really came home to us that we are all part of the water cycle. And without a basic understanding and training programs in place for the on-site professional, we were missing a big sector of that link between public and environmental health and the on-site wastewater profession. So as you can see, our logo here is what we refer to happily as the Blue Lady. And it basically sums up our guiding principle that what goes around comes around. All the water that we have is already here. And yes, we serve the small system sector, but we also serve environmental health staff that are looking for ways to connect with the service providers and also their public, and particularly those that run portable sanitation companies. And we do this by hosting an online and virtual training courses. We decided to focus on this because, and of course, obviously during the COVID years, it became essential to provide this. Many of these folks live in areas where it's really difficult to travel out to physical locations for training. And with our background in data management and web design, we thought we can do this. And we need to do it in a way that reaches people. Because if, as one of our clients said, if you're so bored with what you're watching on the screen that you end up checking your emails or watching a game on another screen, then you've kind of defeated the purpose. So here I am today, if you'll pardon the pun, bringing up the back end of today's session. So I wanted to make a point that the reason I was asked and I put this presentation together is we talked about having 2 steps forward, 3 steps back. And sometimes I really firmly believe that it's the other way around. We make gains incrementally. It may seem like it's so god-awful slow. But on the other hand, I want to remember this. This was the quote from the manager of disease control in the city of Milwaukee. And this is the reason. For those of you who are too young to remember it, and this is part of the problem with being in this business for so long, it's that in 1993, they had an outbreak of cryptosporidium. And that's what you're seeing on the screen there. If you're not familiar with the public health image library run by the CDC, I will, after this presentation, send a copy of all of our web links and our image credits and video credits, because again, I'm so sorry I ran out of time this week with all the other things. But the thing to remember with cryptosporidia is it really wasn't on the radar. And this parasite is protected by a shell, and it mimics the same symptoms of bacterial and viral diseases, which was why for so long it really wasn't identified as the cause. And still to this day, cryptosporidium is listed as the leading cause of waterborne disease among humans in the United States.
right, Dendra, I think the video has no sound.
Of the last century.
There we go.
The water infrastructure itself protects the treated water until it comes out of our taps. It's been since 1911 since we had an outbreak of cholera or typhoid in the United States. But that doesn't mean that it can't happen. It can happen. If we aren't on our guard all the time, we are vulnerable to going right back where we were in 1911.
In Milwaukee, health experts are taking a close look at the public water supply. In Milwaukee, thousands of people have been getting sick.
Private distributors of bottled water are sending extra supplies as fast as possible. Health officials blame a microscopic parasite called Cryptosporidium.
In the 1993 Cryptosporidium outbreak, over 400,000 people became ill with diarrhea, cramping, and nausea. And we also recorded over 100 deaths, primarily in the immunocompromised community, and in particular, individuals with AIDS or HIV infection.
People were beginning to experience symptoms of diarrhea. It started to become more and more widespread, so the natural spot to look was drinking water. So tests were run on the water coming out of both of our water treatment plants. Then we found Cryptosporidium coming out of our Howard Avenue plant.
Milwaukee officials are shutting down one of the city's 2 water purification plants.
Cryptosporidium is a parasite that's found in the gut or intestine of both humans and animals, and found in many surface waters throughout the globe. Prior to 1993, it was not on our radar. It was not a reportable disease.
EPA standards did not safeguard against Cryptosporidium because it was an unknown threat. Once it contaminated the water supply, the treatment plant had no capability to kill the pathogen, so it spread throughout the system.
We saw an expenditure of $90 million to upgrade both water treatment plants.
Cryptosporidium was a wake-up call. It was a wake-up call for us. It's a wake-up call for the nation. Take care of your infrastructure before you have the kind of problem we had.
By no stretch of the imagination do I think we're out of the woods. Recent CDC statistics indicate that up to 32 million cases of waterborne disease occur each year in this country.
But the vast majority of waterborne outbreaks go undetected. When people first get ill, they think, oh, it's something I ate last night. They don't think, oh, it's something I drank last night.
The Milwaukee incident pointed out the potential vulnerability of our drinking water infrastructure in controlling the spread of illness.
It's incumbent upon us to try to stay ahead of the curve, but it's very, very difficult. There's always another bug on the horizon.
In 2008, the Associated Press reported that water quality testing across the nation uncovered trace amounts of pharmaceutical compounds in the drinking water supplies of millions of Americans. The health effects of these low levels of medications diluted in our water are still being determined. But these findings further illustrate the fundamental relationship of infrastructure to health.
We have good health in this country in part because we have clean water. And
So the message there really is, and think about that expenditure of 90 million plus, that's in 1993 dollars. And I once did a presentation to people about the how to message, how to get in front of people and get their attention. And I had this staggering piece of information that most people have the attention span that is less than that of a goldfish, which is kind of disturbing. Anyway, the documentary that's 90 minutes, it was produced by Penn State University. It's still available. The actual link to that is https:/liquidassets.psu.edu, but I will put that into the chat window later. And it is worth remembering that old diseases that were once deemed to be thought to be not present anymore are coming back. And obviously since 1993, we've had a big input in DNA testing. And at the time, it was considered that the Milwaukee outbreak came about because of contamination from animal sources, from feedlots getting into the water catchment system. But subsequent DNA testing showed that no, its origin was human. So think about this. Think about the measles outbreak. Polio, we've seen cases of polio. I would never in my wildest dreams think that we would see polio and diphtheria and TB, which is interesting because if you're again of our age section here, you probably all lined up in elementary school to have your jabs, and we all have at a certain point in our life a scar on our arm from our TB vaccination and never thought any more of it. When my husband was just hospitalized, they gave him another TB test because of the resistant strains of TB that are present. Now, you might be wondering why we're talking about this. And the reason we're talking about it is because of drug resistance, about the serious public health concerns from, and you should be aware as well, of not just drug-resistant E. coli, but MRSA. And again, my husband had to have a MRSA test before he could be treated in hospital. And bear with me, we're getting to the point of why we're talking about bacterial resistance here. Because we need to respect the profession. If our purpose here is to basically provide services, professional services for the wastewater service provider. And the reason is that they deal with all of this. If they are handling human pathogenic material, biological material, if they are coming literally face to face with the business end of human beings, then they need to be aware of this. And it's a bridge, I think, I hope, for our organization, for you, and for the service providers we have to deal with, is we're in the same business. This is the reason we teach a 6-hour course for wastewater professionals on safety, PPE gear, bloodborne and human biological material handling, best practices for safety. And we do this both for their protection, but also for the public, for the people they work with. And all our clients, all of the service providers, become encouraged to then go out and be the public face of environmental health. You may not have thought of them as environmental health professionals, but really they are. We're not this anymore. If this was your idea of what a on-site basic backyard sanitation system is, well, obviously it's not. And we don't send people around with horses and carts and into backyard privies, and we don't ask them to dig it out like that poor gentleman with the scoop bucket there. So unfortunately, that is not a publicly attributed image, but if you are interested in acquiring it, we will let you know. But on that sense, we firmly believe that talking to elementary kids is something that resonates. I think in the environmental health profession and also in the service provider, the wastewater profession, we were talking about this recently at a gathering, that we tend to talk in our own vocabulary. We have a culture of our own making. And when we're talking to elected officials or we're talking to the public, I think we need to have a different approach. A few years ago, we were really fortunate to have a grant to go into a local elementary school for the whole week for groundwater awareness. And I could fill a presentation with some of the stories about that. But one of the things that we talked about was, where does it go? So let's see if we can get this one to play for you. This is Mr. Blakesley. And at the elementary school, we had them have their lunch and then all go outside and watch and realize where their septic system was and what they did. So obviously all the safety protocols are in place there. You can see them all. And as a course during this week in the arts and music section, they got to write songs about it. So we'll keep our fingers crossed that you can hear this.
Okay, this is the fourth graders singing the song about Mr. Blakesley. Up and down, outside of me. They smoke me, eliminate the vegetables and put out to the septic tank. Then permeate, then it waits for Mr. Blakesley. He comes to suck it down. That's what his job's about. So he deserves a shot. We're glad he cleans our septic out. Fifth graders, water show, sand, gravel, and clay. Go. Bang. Gravel and clay. Dirty water all day. Now we can drink it, take showers and sing it, wash some more dirt down the drain. Where does it go from here? Let's make it very. It goes down to Fang. See water all day. Now we can drink it, take showers and sing it, then wash some more dirt off the drain.
So, yes, we had some interesting conversations there because we took over the entire curriculum. They had to calculate in their math class. This was all of the, I think they had 300 and some kids. If they all went to the bathroom at the same time and that the average, 100-pound kid, 50 to 100-pound kid poops at least once a day and it weighs so many ounces. So one of the things that we had a problem with was before lunch, when they knew they were going to see this being done, is the teacher got quite upset about and unnerved and said he did not want anybody going out into the bathroom, fishing one out and weighing it during the lunchtime. But the point is, training has to be personal. If you can't talk to people without boring them to death, you're not really educating. And if you've never had the pleasure of listening to Ben Keel, who's our current board chair, he operates an on-site decentralized water resource company in Australia. They design on-site systems and decentralized systems for the Great Barrier Reef and for some of the most inhospitable places in Australia. So I think the Wet Show recorded all of his sessions. So by all means, do log in to wetshow.com and see if you can access that. If you've never been to the Wet Show, it's in Indianapolis at the convention center every year. Go down for the day. You, I believe, can get CU credits for attending that. And you can see some of the topics that we talked about there. And just to make a point, as the previous speaker was talking about, we're not talking about your grandpa's on-site system anymore. There are multiple options for sites. Some of them obviously do require more management, more oversight, more knowledge, I think, from environmental health staff too, of what exactly they're being asked to inspect and to make sure is working correctly. And so many jurisdictions do different things. But overall, the basic principle is you shouldn't be able to see it on the ground, or it shouldn't come back in your bathroom, or you shouldn't be seeing it on the yard after somebody's been there and done a service for you. And we do emphasize the professionalism of the industry. Septic pumpers tend to get a pretty bad rap. They're particularly prone to being called dumb or not particularly educated. Anybody can be a septic pumper. Well, that's not true. And the other part of this presentation today is just to give you another aspect of some of the things that they have to train for, like this. Some of this obviously is going to be immediately recognizable to you, but these are what they train for and what we train people for. They're dealing mostly with rural areas. And unfortunately, rural areas are not immune from drug exposure and from opioid, meth, and particularly, as we were talking about, fentanyl. All of this is something that your common or garden septic service provider has to be aware of. And unfortunately, the portable sanitation folks seem to get it more than anything. And the common idea is, and particularly if you are as an EH person going out and looking at things like music festivals, community events, fairs, community gatherings, temporary things where there are portable sanitation. This is obviously what you are going to be dealing with. So yes, they need to know about PPE gear and bloodborne pathogens. They need to recognize the symptoms. They know what to do if they reach in or something, as one of the service providers did, which was put his hand up the pipe, see up the hose to see what was blocking it, and came out with 2 syringes stuck in his glove, that this is a reportable event and that he needs to go get checked out immediately. They need to have appropriate vaccinations, but as an employer too, of course, you need to know what the HIPAA regulations are for somebody that decides they don't want to be vaccinated. They need to know how to report the accident. And you may think this is a big public event, but this particular one was in somebody's backyard for a graduation party, which shocked the heck out of the guy that sent me this photograph. Just goes to show, I suppose. So now the previous speakers talked about different types of systems and the efficiency and the appropriateness. In our mission statement, you will see that we advocate for appropriate systems in the best possible location. And this is one of Ben's systems for Lake Googler, and this is in Woodford in Australia. And if you've never heard of it, Woodford is the largest music festival in the Southern Hemisphere. It runs between Christmas and New Year every year. Around 400,000 people attend it over this period. And in 2019, they installed this natural 3 million gallon natural swimming lagoon. There are no disinfection chemicals are used. It's actually filtered from upflow rock filters and beneficial microorganisms. After the event, if anybody wants more information about this, there is I believe, a YouTube and a Vimeo recording on our website. The lake is actually stocked with fish and reptiles, birds, eels, and mollusks. I'm not quite sure about swimming with eels, but apparently people love it. Up to 6,000 people a day can swim in this lagoon. They allow up to 500 people an hour. The interesting thing about this and why we're talking about it is that Woodford hosts different festivals throughout the year, not on that scale, but Ben also runs water testing for them. And it's really interesting how the difference in what they find mirrors the age of the people who attend. Like Googler, because it's a music festival primarily geared toward people of 50s and 60s. They do a lot of really good 80s and 90s and early 2000 music. He did make the point that the last time they did testing, they found an awful lot of Viagra. But at other festivals, it goes back to the regular methamphetamine and other unpleasant things. But this crosses over into our other disciplines here. The identification of upstream human activity being indicated by what ends up at a treatment plant. And in 2020, we hosted a set of Australia recorded events. And again, they're on our YouTube channel. One of the researchers is Dr. Jake O'Brien. He's a fellow at the Queensland Alliance for Environmental Health Sciences at the University of Queensland. He's also the chief investigator for the National Wastewater Drug Program. And the biomarkers that were discovered when they sampled wastewater treatment plants was quite shocking. In subsequent years, they've amended the testing, and now here as well as there, that DNA biomarker and the residual RNA has been found to identify things like this, which is hepatitis B. And the thing to remember there and why it's applicable to you as well as to the service providers is that people can become infected, be infected, and they don't feel sick. They can touch something. The virus can live for up to 7 days on an object. And I'm not quite sure how this pans out with having 500 people, 600, 500 people swimming in the same place as you. But then we start looking at things like this nasty little thing. I suppose I do have to watch my language. I would call it something else, but drug-resistant drug-resistant bacteria. Again, poor husband, he got as many shots in the arm from things he might have been exposed to as what he actually went in there to be treated for. They are extremely concerned about people being infected by what this is, which is CRE. Last I checked, there were over 9,000 healthcare-centered infections from CRE, but this stuff matters. And the people who work in both the environmental health and in the wastewater, the service profession know this. And that's one of the things that perhaps we don't do enough to communicate to the general public and to our elected officials, that this stuff is serious. This stuff can kill you. And of course, the obvious one is COVID. And, benign as the title sewer mining for data actually is, it really shows how careless we've become in paying attention to what the professionals do and also to the science of what we do. Recently, I noticed, as you probably realized, I became a citizen back in 97, I believe. But my origin is the United Kingdom. They held 5-year anniversary memorial services for when the onset of COVID arrived. I actually had COVID twice. Last time was pretty unpleasant, and I would have been in hospital if they'd had any room. I would have had oxygen if there'd been any on my island. The reason is, of course, that we have things like this as well. And follow the thread here about antibiotic resistance, about the occurrence of C. difficile. And again, he was tested repeatedly for this because it is becoming more frequent and it is a severe threat. Because I don't know how to stress this enough that it's associated with the overuse of antibiotics, and that the overuse of it becomes the key to making resistance. C. difficile is a serious infection. And when we teach this class, there are some people that know what it is, and there are some people who don't. And finding ways to get across to people is absolutely critical. And if you're not familiar with it or you haven't seen it, last year, I believe it was, PBS hosted a wonderful series called The Invisible Shield. And it was a 4-part, I believe, 4-part episode of the different ways, the playbook of how we got to the point where perhaps we realize why people either aren't aware of or don't trust the information that they receive. And as we've seen from that clip way the heck back in 1993, it's been since 1911 that we had cholera, but COVID topped everything. And although we had made incredible strides to increasing lifespan, underfunding and disinformation and skepticism instilled about science and about environmental health puts people's lives at risk. And how we communicate that with people, I think, is really important. And we need to think about what this is and the transportability of antibiotic resistance. We live in a world where something that happened and originated in China can sweep the world. And here's an example from a few years back.
I was a doctor in Iraq with the Air National Guard, and I can tell you from firsthand experience, the survival rate for wounded soldiers, it's a remarkable story. But it's one with a downside.
That downside comes in the form of a tiny microbe with a powerful punch. Here's the culprit. It's a bacterium called Baumannii, referred to in Iraq as Iraqibacter. Like most bacteria, this tiny single-celled organism lives in colonies and is constantly reproducing, simply by dividing and dividing again. A single bacterium can give rise to 5 billion trillion in only a day. This bug used to be relatively harmless, yet somehow it's found a way to transform itself into a drug-resistant killer. Many soldiers and civilians are picking up this deadly microbe in hospitals along the evacuation chain out of Iraq and bringing it back home to America, where it's infecting even people who have never seen a battlefield.
It has this ability to hang around in places where it ought not, like on doorknobs and pillowcases and the like.
Where it can survive for weeks. So why not simply use an antibiotic like penicillin to fight it? But something has changed. Now the bugs are fighting back. Microbiologist Mike Smith demonstrates how drug-resistant this bug has become. He places colonies containing millions of bacteria in several petri dishes and confronts them with imipenem, an antibiotic so strong it's nicknamed gorillacillin. After 12 hours, all the bacteria should be dead, but they're not.
Unfortunately, this is the kind of thing that we're seeing where certain colonies are surviving. So the entire population now of remaining bacteria are imipenem resistant. So this is the strain.
Smith and graduate student Tara Janulis prepare a sample of Baumannii. Its DNA will be sequenced, one letter at a time. The results reveal that Baumannii has large sections of genes that don't belong. foreign genes that are giving it resistance to antibiotics.
There is a multi-drug resistant strain that took 45 different drug resistance genes and stuck them in one spot. This should be alarming because that's what this bug can do.
How is this possible? There's only one way we get our genes, and that's from our parents. It's called vertical gene transfer. But it turns out bacteria can also get genes in a process called horizontal gene transfer. One way that happens is when two bacteria get together for a little friendly conjugation, the microbial form of snuggling. They form a connection and squirt DNA into each other. Turns out Baumannii has been getting a little too friendly. Could that be what's making it so nasty? To find out, Mike Smith zaps a colony of Baumannii with electricity, creating over 1,000 mutant bugs, each one different, each one missing one known gene. He takes these mutant microbes and feeds them to some microscopic worms.
And it turns out that when these worms eat disease-causing bacteria, it often kills them too.
Just like lethal bacteria can kill us. But if Mike has succeeded in zapping out the lethal genes, then some of his worms should survive. Will it work? He'll find out at dinner time. To survive, give Mike the information that he needs to know who Baumannii has been getting friendly with. It turns out one of the deadly genes comes from a well-known killer, the bacteria responsible for Legionnaire's disease.
It's taking in drug resistance gene and it's developing drug resistance. It's taking in virulence or disease-causing type genes and it's using them.
With the addition of some new genes, Baumannii becomes more lethal and harder to defeat all at the same time. It's an ongoing battle, not easily won.
Perhaps instead of trying to just overwhelm them and kill them, maybe we can coerce them into doing something that they weren't thinking about doing if we understand how they communicate.
But bacteria have been around a lot longer than we have, and they are very good at adapting to anything that we throw at them. So for now, it's a matter of early intervention, better hospital hygiene, and good medical care.
Yeah, that's a little scary. It really is. And excuse me. This is why we place so much emphasis on good basic safety training. And that picture there in the top left of your screen, it makes me very angry when I see some presentations about how to service wastewater systems or how to do installations. You should never be seeing somebody's bare hand. You should always be seeing somebody wearing safety gloves, safety goggles, and a helmet. A hard hat, because we'll talk about that here in a bit. Because you, me, all of the service providers we work with, work at the business end of human beings. And if there's two things in life that's certain, which is death and taxes, then maybe we should add a third one, which is everybody poops. And this is, again, what we train for. PPE gear, confined space, digging and trenching, all of the things that will render you to have some really concerning OSHA violations. I often wonder if that guy was standing on top of a lid that he was digging up, but then, like I said, people do dumb things. So again, when you're out there talking about site evaluation, we find that a picture really tells the story. We can read PowerPoints off us and we can talk to people, but if you can show them, if you can walk them around their site and talk to them in a language that they can understand and see with their own eyes, It it might be a chore, but on the other hand, this is why we have soil scientists. It's why we have soil evaluations. And again, on the principle of looking for ways to connect with what people can recognize. We do a series every year for all of the occasions. We do PR pieces, and these are all free. If you see them on our site and you want to download them, by all means do. If you want a copy of these, shoot me an email. I'd put that on the first slide, but I'll put it in the contact list afterwards. Things like this. And yes, the stories we hear from individuals who are in the business, and if they get called out on Christmas Eve to pump a septic system, they are not happy campers. And occasionally, of course, things do go wrong. Things go really wrong. And in this particular case, someone permitted a mound system, which you can just see in the back there. And the service provider actually said, this is not a good place to put this. Because if you could see all the way to the right of the screen, which for obvious reasons I'm not putting in there, this is a small party store, gas station. It had a name brand sandwich distributor. When it rained, all the water came off their parking lot and drained into this area. When it rained really badly, it went down a drain and into their mound system, which also drained into this area. So sometimes it's kind of obvious what's wrong, but then there are other things that go wrong and nobody really knows why. If you would do us a big favor when you're out and about, if you come across any examples of microbial induced concrete corrosion, and this is caused by an excess of hydrogen sulfide that reacts with the chemicals in the tank, precast tank, obviously, and also with the components of the tank itself. It can literally reduce a precast tank to a nasty, soapy, squishy mess like this. But the mystery is, why does this only happen in certain areas and not others? So again, if you see this, please let us know. But these are the things, again, that service providers are looking for. And some of the things that the previous speaker talked about, yes, if you've ever seen the blue collar column tour, you know that you cannot fix stupid. But this bare, flat piece of unprepossessing looking backyard is actually the septic tank and the drain field. And you can see it was a nice open area. So the owner thought it was fun, just a good place to park and pile his wood on the back side of it. So yeah. And then of course there are things that can quite literally bite you in the butt. We live in an area with a high feral cat population. So what you're actually seeing there is a microscopic image of the Yersinia pestis, the bubonic plague. And if you think bubonic plague isn't something we have to deal about anymore, well, again, check out the CDC website and you can pull up Illinois, and you may already know how many cases of bubonic plague have there been in Illinois this year. We live, regardless of what other people may say or profess, in a time where the climate is changing. We tend not to use the word climate change because it tends to get some people very upset, but you can't deny that areas that were wet are getting wetter, areas that were dry are getting drier. We're experiencing extended periods of drought and heat followed by monsoons of rain. And if people like to move away from that, well, so do the insects. And tick-borne disease is an ongoing problem. And everyone who works in this business, you, me, the septic service providers, are in people's backyards. They're in places where it's quite possible that they're in overgrowth, and they're quite probably going to be encountering these. And in Illinois, you are prone to American dog ticks, Asian longhorn ticks, black-leg ticks, brown dog ticks. And I put in there the Lone Star tick. Now, the CDC website says that you don't have them, but it also says that Michigan doesn't have them either. And there have been reported cases of Lone Star ticks found on Western Michigan. So I think it's fair to assume that you've got them too. So these are things that can literally bite you in the butt. This one is hysterically mine. There isn't actually a tank in there at all. Put the hose down into and couldn't see a tank underneath it. So this is what he found was a straight pipe going out into the field behind his house. And again, we won't identify where this was. This one's ingenious. As you say, it's pretty homemade. Those are actually two, I think they're 15 or 20-gallon pickle crocks put together. And when one is positioned a little bit lower than the other one, so when one fills up, it spills over the top into the next one. Quite ingenious. And this one is one of my favorites that was sent. This is a good example why you never leave your neighbor's teenage kids to house sit for you when you go away for a week vacation, because this is what you might find when you come back. And if you think back to all of the pathogens and blood-borne things that you can contract if you come in contact with this, it's a pretty unpleasant thing to pull out of anybody's drain. So we also, of course, need to talk about basic electrical safety, because some of the advanced treatment systems that we've looked at refer to electrical components. And if you're not familiar with arc flash, let's see if this will play for you. And watch the screen again. 480 volt, 3-phase arc. Yeah, the explosive power of arc flash and the danger inherent with electrical components from advanced systems is something that needs specialized training. And part of the reason we do this is to give people enough knowledge to realize when they should not be touching anything on this. And obviously that includes you too. So again, we're talking about what we train for. Vacuum trucks are inherently dangerous pieces of equipment. Injuries, deaths happen every year from people who do not know how to properly respect the power inherent in those pump systems. Liquid cargo awareness, that as you're driving down the road, this cargo is liquid. It doesn't stop on a dime. If you try to, it will keep going. And things that can happen on the job site. And the note here is remember not to park by the trees next time. So watch what happened to this guy. That's how close he came to losing his life and his truck. So, in conclusion, we're wrapping up here now. We're privileged to work in a profession that safeguards people and the environment at the most fundamental levels of life and safety. We see the daily assaults now on the hard-won knowledge and the science of our shared professions. And sometimes it can seem like we're losing that fight. But to learn the lessons, are we smart enough? And in the end, if we don't, who will pay?
The prospect of life without antibiotics is barely imaginable for a world that has had a cheap and plentiful supply of them since the end of World War II. They are a staple of modern medicine, It's hard to recall a time without them, when an infected cot could kill a healthy young person in a matter of days. But it's now clear that we are heading back in that direction, that the miracle of these drugs is slipping away.
Antibiotics are unique drugs. They're not like any other class of drugs. 50 years from today, the cholesterol drugs we have now will work just as well as they work today. The cancer drugs we have now will work just as well as they do today. That's true of all the other drug classes. Antibiotics are the only class of drugs that the more we use, the more rapidly we lose. When you use it, it becomes less effective for me and vice versa.
That is the essence of antibiotic resistance.
The more you expose a bacteria to an antibiotic, the greater the likelihood that the resistance to that antibiotic is going to develop. So the more antibiotics we put into people, we put into the environment, the more opportunities we create for these bacteria to become resistant.
But people forgot about the danger of resistance because the drugs were so effective.
And what they had forgotten was the warning that Alexander Fleming himself, the man who discovered penicillin, gave us in 1945, that resistance was already being seen, and the more we wasted penicillin, the more people were going to die of penicillin-resistant infections.
Bacterial resistance is largely inevitable, but it's also something that we have certainly helped along the way. We've fueled this fire of bacterial resistance. These drugs are miracle drugs, these antibiotics that we have, but we haven't taken good care of them.
Public health officials estimate that up to half of all antibiotic use in the U.S. is either unnecessary or inappropriate.
And in overusing these antibiotics, we have set ourselves up for the scenario that we find ourselves in now, where we're running out of antibiotics.
It's a sobering thought that the next time you have to go in or you admit a family member for a hospital procedure and they're going to need antibiotics. Again, this is one of the humorous things that we put out every year to mark occasions. You know, not just the run-of-the-mill tooting our own horn things. I had a caption for this one was everyone is entitled to the pursuit of life, liberty, and life, liberty, and happiness, and two-ply bathroom tissue, please, but no wet wipes, because we know what they can do. And so it's worth reminding ourselves of, sometimes it can seem so depressing of what we have to deal with. You know, this photo is the iconic Christmas Eve photo from 1968, taken by William Anders. At that time, you know, it shows that they were orbiting the moon, and it became known, of course, of the pale blue dot. It was at that point, the biggest audience in television history. How many billion people tuned in to watch that? I think it's one of those things, if you're our age, you all remember where you were when we had our first steps for humankind. But every day that we work for, every day that we have to do this job, I feel privileged. This is something that gives me a lot of pleasure, makes me angrier than heck at times, and I'm sure it does you too, but it's a privilege. You know, that's the difference in the one that was taken in 1998 to this most recent one of the blue dot. And just to make sure that everyone remembers what we're talking about here, to put it in perspective, that's us. That's the pale blue dot. Everything in there is everything that keeps us alive. Every speck of dust, everything that we grow to eat, every molecule of water, every molecule of air that we need to keep us going. And this was captured, this image, as the Cassini satellite passed through the rings of Saturn. And then I think that really puts in perspective what we do and why we do it. Politicians come and go, but in the end, we have to hold on to what we do and be proud of what we do. And I'm not sure if this will play, but I will play this as we go out. So with that, for all of you on this good earth, we wish you work safe, be healthy, be happy, go about your daily job. You are heroes.
All right. Thank you so much, Dendra, for your presentation. Let me see. I don't see any questions in the chat. There's been some questions about CEUs that has been posted in the chat of exactly what you need to do in order to get your credits for the sessions that you've attended. Let's see. Justin, is there anything that you wanted to add before we wrap up?
No, we're right at 4 o'clock. Thank you, everyone, for attending the Spring Virtual Conference 2025. I think we had an absolutely amazing round of speakers this year, once again, and learned so much. And Dendra, thank you very much for speaking. And if you do have any questions, always feel free to reach out to the speakers. CEU forms, our office sent them out. If you did not get those forms, please reach out to the office so we can resend them to you. Do check your spam folders. Sometimes they do wind up there. And then once you complete those forms, send them back to our office, and Heather will get everything completed and get your certificates of attendance out. Once again, thank you everyone for another wonderful spring virtual conference, and everyone be safe.